Okay. Well, today at least I'm in my office, so hopefully things will go a little better.
Quality is already looking better.
Yeah. And I found a version of OneNote for Ubuntu. So that maybe is going to hopefully will help. A lot of these notes I did originally in OneNote, so I'm hoping it makes it um, a little easier. So somebody was working on the homework, and I thought we had given you the big step for semantics for A expressions before, where you ended up using the variable, but he pointed out that no, you guys didn't do that. We just skipped the variable. And so if you look on the homework, I put up the code that would give you the semantics for A expression evaluation using uh, the state, which was a function that maps um, strings to ints. And now what you're going to do is kind of like essentially environment to say Q now gets bound to call P, and so these two stay the same. On line 6, basically nothing happens. We're just entering the begin block. On line 7, what we do is we say, okay, location, what's the next location to allocate? Location 2. What's the value that it gets? It gets 9. And now X points to location 2. On step 8, we redeclare P. We kind of like hide this P where P says X gets a value of X plus 3. And now we have P is X gets a value of X plus 1. And we don't change the variable environment. So then on line 9, the crucial thing is essentially on line 9. We say call Q. And what do the semantics for Q say? They say look up inside the environment, which is the same as this one, Q. And Q says call P. Okay, so now the next thing that we're going to do is call P. So we look up P in the environment, and P says X gets the value of X plus 1. The original P, I'm trying to scroll up, the original P said X gets the value of X plus 3. But now we've got X gets a value of X plus 1 is the entry that's in the procedure environment for P. And so the store down here gets changed so that location 2, which is where X points to, that's a 2 there. X points to location 2. And so location 2 gets updated to be 9 plus 1 is 10, if you can see that 10 there. Calling something does not change the environment, either environment. And on 10, we say Y gets the value of X. And so there we look up Y in the environment, which is this one, the variable environment. It says Y points to location 1. And so location 1 gets the value of 10 now, whereas it was 42. And then that's the end, essentially the end of the program. Nothing else changes there, except that when we exit a block, we do get rid of, so maybe I should, let's see, what did I do here? I did say when we ended this block on line 11, we went back to the old version of the environments. So these just get disappeared, and we're back using the one, I wish I could scroll one line. Oh, I sort of did. Yeah, so you'll notice this is X gets the value of X plus 3, because that's what was in place before we entered this block. But when we enter this block, we go back to the old environment. So you got to see how that works in the, we'll need to look at the begin end block semantics to see how that could happen.
So when you go back to the old environment,
Yeah.
does the environment that you're in go to some sort of dump state, or does it just stay in the same spot in memory?
This one? It
Yeah.
just kind of is inaccessible. Yeah, I mean, it would still be in memory. Like, we don't actually reclaim the space from it like you would have to do if you were programming in C. But no, it becomes garbage. So the garbage collector will get it. Let me see. I'm not sure I have the declaration rule here. Let's see. I think we talked about it though. Oh, let's see. we talked about it in here. I think we have, did we put down the rules in here? Yeah. So here's the big step semantics rules for a block, for a begin end block. And so got the environment, an environment, right? And then the first thing I do is I evaluate this declaration in the current environment and the current store. And so I get back a modified environment and I get back a modified store. And then I use those to evaluate the body. Now, this could be a bunch of semicolon separated stuff. So probably it's important maybe here to put down the semicolon rule. So this one modifies the environment and then it evaluates S, which is, you know, this sequence of possible sequence of statements, this statement S, which is in the begin end block. And then it returns a modified store, STO prime. And then in that store, we have to set it so that, oh, yeah, we got to reset next to what it was because we want memory to grow and shrink like a stack. So we reset the store. There may, like in the, and so in the thing that we were just looking at, the store gets shrunk back also. Okay, I gotta scroll up. If you look here, the store here had X equals I can't read it, 2. If I zoomed in, we could read it better. Log 2. But then when we exit that, I made a mistake in this thing. I should really, on line, oh no, I didn't. On line 11, I go back to the old store. Now X points back to 0 after you exit the block. So if you look at the code, when you come in here, you're making local declarations. You allocated a new location, location 2, but that location disappears. Well, so that's a curious thing. What it doesn't actually disappear. What happens is we reset the next pointer to be location 2. So if you never allocate a any more storage, it's still there, and the max will tell you, oh, the max was 2. So you could look at storage that's beyond the, you know, that's beyond what was allocated initially in the beginning of this block, even though you have no access to it. Because if you declare a new variable, it's going to use the same location that was used here again. Does that make sense?
Yeah, I see what you're saying.
If
So
we,
like the location is still, it's still there. We're just, it's
in the store,
inaccessible.
it's
It's out
still
of our
there.
scope.
And in the environment, we just kind of like, so what happens when you do, oh, I'm not editing this. Let me quit it. Let me get back into it and edit it. Remember the semicolon rule. So we've got some env and we've got a S1 semicolon S2, and then we've got some store. What is that going to evaluate to? Well, we take S1, we take the same environment, and we evaluate S1 alone in the store, and that returns a store, let's say double prime. And evaluating a command does not, you have to evaluate a declaration to change the environment. So here's where we go back to using the same environment that we started with. But we use the updated store from the previous command, from S2. So this should be S2. From evaluating S1, that should be S2. And we get STO prime. And so this becomes STO prime. So the way of it, the way that we evaluate a sequence of statements, S1 and S2, kind of just keeps using the same environment over and over again. So that's why here we go back to the environment that was in place before this block was evaluated. So this block was evaluated. That's just one statement. So we had, this declaration, semicolon, this statement, and we could have had a semicolon here in another statement. And we evaluated this. And in fact, that would have been maybe a good idea, would be to put, he has an example in the book where he thought, oh, I better add that. And he puts down below here something after this. He puts something like a Z equals X, but he forgot to declare Z. So that program is kind of meaningless because there will be no entry for Z in the environment. I forget what page that's on. It's a little bit later, and he sort of realized, I think, like I just did, oh, I should have had a semicolon after this and do something else to maybe better illustrate how that rule was working. Well, I won't let me do that. That's annoying. All right, so we don't have much time left, but I mean, I think asking questions is good. This is the one you're going to have to implement, is lexical scoping. And in lexical scoping, I'm sorry, static, or it's sometimes called lexical scoping, but it's also called static scoping. And this captures the idea that the bindings in scope at the point a declaration is made are the ones to be used in a call. So like up here on this program here, instead of calling, oh God, this is so frustrating. I can't move the page around with any kind of control. It jumps. Oh. So anyway, up here, he redefines P, but Q was defined using this P. So when you call Q, in this version, what we did was we said, okay, look up P in the environment And the P that's in the environment at that time is the one that says X gets the value of X plus 1. So if you don't, so the way to fix it is to not just put the statement in the environment, but to put the statement together with the store. So like Huddle's rule says, and here's my rule. Huddle's rule is that in environment, you give it the variable environment, remember to evaluate a statement for him, and we just build the environment in. So you see a proc P, a declaration, and the body is S1, and then it's followed by more procedure declarations, and you're modifying ENVP prime. And so what do? Well, you modify the rest of the declarations, DP, these here, in the modified procedure environment that's been updated, not just to have S1 built in, but to have the variable environment built in and the procedure environment built in. And then you're going to return a modified ENVP prime, which if DP is the empty one, is just this environment right here, the one that has P built in pointing to S1. For our code, the code that I'm going to give you, you kind of do it all at once. You say, okay, proc P is S1, and then you've got more declarations to evaluate, and you've got an environment and a store. And so what do? You evaluate the remaining declarations in the new environment where P has taken it, where the procedure environment has taken into account that P, which is the name of the procedure, now points to S1 and the environment. So what does the call do? So the call is going to use that environment. So, I mean, this is, to me, this is so cool how this works out. I think this is just an amazingly beautiful mechanism here. So you see a call, and so a call is a kind of a statement. You've got an environment that has your variables and your procedure stuff all in one package. And you want to see, what do I do when I want to call P? And so what you do is you look up in P two things. Now you get back when you look up in the environment P. You get back the statement, which is the body of the procedure, and you get back ENV prime. And so now what I do is I use ENV prime here as the, you know, over here, I'm using, well, that's not what I was hoping I'd get that. Okay, yeah, I don't know. Anyway, over here, this ENV prime is the one that you used, and that's what you use to evaluate S, but you do it in the current store. And so that will return a store, some store prime, and that's the result of this. So you might think, well, nothing is going to change. It's always going to, but the store has changed, has evolved. So I think maybe we have just enough time. Here's the same program, but now we're going to evaluate it using these rules here. When we saw the declaration, we put away two things. We put away this, is that the one I want? No. Yeah. Oh, when we saw the procedure declaration, we put away two things. We put away the body of the procedure and the environment and the store. And we do the same thing. We put away in the environment P gets bound to the current store, the body of the procedure and the current environment at the time. So let's look at how the evaluation goes. So nothing happens here, then we declare X, so this looks the same as the dynamic. We declare Y, so this looks the same as the dynamic above. Now we declare P, and so it's kind of hard to see, but I've labeled this environment ENV3. So P points to a pair, which is X gets the value of X plus 3, together with this environment, ENV3. And then when we declare, well, and you can see it maybe clearer here. And then when we see Q declared, Q's body is called P, and it gets to use ENV4. Well, ENV4 is the same as ENV3. Nothing has changed. And so then on line 6 is the begin. Nothing changes. On line 7, we declare X. So now we have a location 2 that points to 9. And now X points to location 2. And so call Q, and what happens? When I call Q on line 9, I call Q, and that says call P. And so then when I call P, it says the entry for P was this one. Why is that? Wait, this is confusing me now. Am I still doing dynamic? No, it should be lexical. Oh, Q is not defined here. So Q says call P using environment 4. That's the one we had up here. Right. And so when you call Q, that calls P using environment 4. And then environment 4 says, oh, P is equal to X gets a value of X plus 3 using environment 3. And so that's the same as this one here for the variables part. And so X now points in that environment, X points to log 0, and log 0 has the value 0. And so now we increment location 0 by it should only be by 1 though, right? No, 3. Right, this one is 1. So it increments, location 0 gets incremented by 3. And so now we have 3, 42, and 9. And then on line 10, Y gets the value of X. Now the X that's in scope here is this X. So Y gets the value of 9 now. So log 1 now has the value 9. And on line 11, we revert back to the old ENV4 things. And then on line 12, when we exit that, all we're left with is the store that looks like this, except that the next location to be allocated, which actually would have changed here, is that its location 2 is the next available memory location. And when you exit the block, those things disappear too. All right. We have, I don't know, what, 7 minutes. Questions? Because this is going to be the next homework. I'm going to give you this dynamic, and you're going to have to implement the lexical.
Would
Are
you
these notes
post?
posted online?
I haven't put it up yet. It's you're currently doing one where you do side affecting expressions. And the next one is going to be to do implement static scoping. And so I can put it up, make it active right now. When should it be due?
Well, I was talking about the notes.
Oh, these?
Yeah.
Yeah, these will go up on the
Could you
webpage.
post the recording of this lecture too?
I'm going to
We can
try.
rewatch it.
Yeah, I'll try. I think I can do that. Now, unfortunately, I don't know, maybe I should actually continue sharing my screen in case anyone has a question about what we've done there. I don't know. Unfortunately, I'm not going to be, well, it's very fortunate actually. I'm going to get my second vaccination, but I'm leaving like, it's at 3:00, so I won't be at the office hours today. But I may have enough time after this ends to process this video to get it up so that I can share it. I hope I'm recording though. Let's see.
Yeah, you are. I have
You
the
can see it?
recording thing
Okay.
in the corner.
Okay, good. So any other questions on this? I'll put these notes up and you can study what's going on here. But see, when the key here is down here is that when we declared Q, this was the P that was in scope. So when we call Q down here, Q says, call P, but it also has the information of which environment to use. And the environment to use for P is, so when I look at Q, so this is line, this is line 8. P is redeclared, but Q still says call P. I didn't write down. Huh, how come? Am I looking at the wrong one? I'm sorry. This one's looking at the wrong one. Here, when I say call P on line 9, so on this line, P, I'm sorry, when I say call Q on line 9, on line 9, the environment that's in place says call P, but is the body of Q, but use the environment that was in place back up here at the time that you declared a Q. And so then I would think like for him, he should have had a call P here too, because what would happen if you called P? If you called P down here, the P that's current is this one. At this point, P is X gets the value of X plus 1, use environment 7. So it would have been really useful maybe to have a line here that said call P, because you'd see that this one is the most recent declared. Oh, this is an interesting thing about the way these semantics work also. If you have a program that says var x equals 0, and then the next one is you redeclare x, var x equals 7, you'll never have a way to refer back to that original x. These semantics allow you to declare a variable multiple times, like in a row, but the only one that you're going to see is the one that is the last one. And that's because the way declarations are evaluated. And I think in this we have the way here's how a variable is evaluated, right? Is that you call the allocate function to get the new location and the new store that's been extended. So in this one, next points to the next location. And then you evaluate A in the store that was in place at the time you saw this thing. And that returns some value K. And then you modify the environment, the original environment, so that now X in the variable part of the environment gets bound to the location L, which is the new location. And then the new store is the one that knows that L points to the value K. So this is like, it's still kind of a baby language, but you can write some interesting programs in this. No more questions? Let's see. How many tests? Well, what is one question? I want, yes. Oh, good. Tim Bork got it. I want you to do as many tests to make you feel like your code is working. Yeah, that's right. Thanks, Tim. Okay. Well, I will try to get this uploaded before I race out to get my, well, I don't have to race. It's not that far, but leave to get my second vaccine, which means that I'll feel much more comfortable coming here. So anyway, okay. Thanks for showing up.
Thank you.
See you.